Let's talk about another linear inequality. So it's linear and an inequality. I had a question from a student about this, so I'm going to try to clarify, make things better than I explained on a previous video. So here we have a linear inequality, and what we're going to do is get this in slope-intercept form. So I'm going to begin by subtracting 2x from both sides. Now, these are going to cancel, and the result is going to be this. So hopefully you see how that worked. And so then the next thing I need to do is to divide both sides by -3, because I'm trying to get rid of this -3 here. So if I divide by -3 here, these will cancel, and that'll leave me with y. And then I've got to divide this side over here by -3 also. Now, hopefully you are familiar with the rule that says if you multiply or divide both sides of an inequality by a negative number, you have to reverse the direction of the inequality. So you'll notice I reversed this because I just divided both sides by a negative number. Now over here, a negative divided by a negative is a positive, so it's positive 2/3. And over here, 4 divided by -3 is going to be -4/3 because the negative goes with the top number. Okay, so this is the slope-intercept form for that linear inequality. Now, when I go to graph this, -4/3 is about -1 1/3. It's about right here. If you do that on a calculator, it's like -1.3 repeating. So that's here, and then I go up 1, 2, and over 1, 2, 3. So my other point is here, and I draw a dotted line because this is greater than. So I draw a dotted line through that. Now I'm going to determine how I'm going to shade. Now there are a couple of ways to do that. One way is just to look at this. Since that says greater than, what I'm going to do is put my pencil on the line here and go up. Pencil on the line and go up. Pencil on the line and go up. So what I know is that all the shading is going to be above this line here. And by heavily shading this, what we are saying is that all the points above the line would be solutions to the original problem, and all the points below there or on the dotted line would not be solutions to the problem. So that's one way to do it. That's the answer. That's what the graph looks like for this inequality. Now, plan B is to take the original problem and to do a test point. So here was the original problem. I'm going to do a test point of 0, 0. By the way, when you look at 0, 0 here, 0, 0 is right there. So to determine which way we should shade, what we do is we plug 0 in for x and 0 in for y, and we do the math. Now, if you do that, you get 0 is less than 4. Well, 0 is less than 4. So this is true. This is a true statement. So that means since the test point is here and it was true, we shade towards that test point, which ends up being up. So the graph, by just going by the fact that it was greater than, agrees with a test point of 0, 0 proving true. So we shade towards that test point and it would be shaded above the line. Now let's do another test point. Let's suppose that we used 0, -5. Now 0, -5 is definitely down here. It's not in the shaded region. So 0 and down, -5 would be about right here. And when I put that into the original problem, I put 0 in x's place, I put -5 in y's place. You do the math, 2 times 0 is 0. -3 times -5 is 15. 15 is less than 0. Well, that's not true. That's false. So that gives me a false statement, which means since that test point, 0, -5, is here, and it was false, I don't shade towards the test point. I shade away from the test point, which would also agree with shading above the line. So we shade above the line. So what I'm saying is this: we would shade above the line based on this. We would also shade above the line based on the test point 0, 0 because it proved true, so we shade up. And then we would also shade above the line with this test point because it proved false. So we don't shade down, we shade up, which is in the other direction. Well, I hope this clarifies things and makes a little more sense. So the graph looks like that. You should try this one. I think it's worth writing down the original problem here and putting it in slope-intercept form, and then looking back at this video and see if your picture agrees with the one that I have. See ya.